Hi guys, good afternoon. This is this session 102 of Story of Fluids. That we have started last week, and since we are not exactly following the common syllabus for these subject like fluid mechanics, as I mentioned in the flyer, that we'll cover all types of properties of fluid, and that we include, let us put the date first, is 22nd Jan 2022, and we are in this session 102. So what we are trying to give you the picture of this fluid properties, that starting from is physical, chemical, as well as thermodynamic properties. So that you able to understand that whatever things actually happening around you is like drops of rain flow in the river, and also cloud formation, rocket launch, and we are trying to cover everything from very first beginning of the fluids. Basically whole earth was a fluid. It's a kind of plasma, liquid, some solids came later. So fluid was maybe the more older than the solids. So definitely we have to look into the fluids very critically, and that's the critical subject will be there for times to come, and for years to come, because nowadays we are looking for the space journey. We have started kind of space adventure. We are going to the age of the atmosphere, and maybe within decades we'll start moving towards outside space. We already there in Mars, in moon, but maybe we'll go farther. So everywhere, wherever it is a rocket launch or it is a flow in the river, so everything connected to the fluids. So that's why the fluid is important, and we are looking into the different properties. So physical physical means what you see, what you can kind of feel directly physically. So it is maybe we can talk of color, we can talk of its kind of density, what you can even take a weight or take a measurement with this. So density, color, viscosity, these are coming from the physical point of view. So that is there. We also talk about the chemical properties, and chemical properties definitely it is how it react. So it is not always water that we see most of the time, or water droplets that is everywhere around the world, but there are different other fluids like acids. We have different alkali, different kind of fatty acid, liquid fatty acids, oil, everywhere there, that they have some reactive properties. So those reactive properties like the pH, the concentration of different minerals. So these are basically the properties that we definitely look for as properties of the fluid, that is a chemical properties. And the third one that we are trying to cover in this session, that is the thermodynamic. So thermodynamic properties, that is very important because nowadays we are looking into the climate change, and that is because of uh, temperature rise. And when the temperature rises, they bring some more heat energy, and heat energy is definitely being absorbed by the fluids that is everywhere present, and as well as solids. But the way the fluid absorb this energy is definitely different from the solid, so that actually that creates the whole weather patterns. And from people living near to the shore, they will feel every time in a day there's a changeover of the this fluids that maybe inform the gases, and maybe if there is a rain, and so that is again flowing down to the river or the ocean. So that cycle goes on, and that is because of this thermodynamic imbalance in the system. So thermodynamic properties like specific heat, uh, you can think of entropy, enthalpy. So all of these are very important for understanding the fluid. And whenever you are working on the fluid, I just mentioned my project, and you can just think of your own work wherever you are working in some industry, or maybe you are an intern or you are a student. So everywhere we do whenever you do an experiment, we use some liquid for the fluid mechanics classes, so that is there. And also we definitely take up the wind things. So if you are in the wind engineering, the wind pattern, wind properties, and if you look little bit kind of away from the lab scale, so regional scale, or if you talk about the continental scale, or if you go maximum, that is our planet scale, so global scale or the global circulation patterns, so that is very much become important nowadays. It was already there, it was since the beginning of the planet, when we have started having the atmosphere. So that was there, but with the paleogeological formation or the ages, there were a lot of changes has happened, and there were a lot of cycles. One is definitely in the equator, we have the heat maximum getting absorbed from the sun, and at the poles it is very less. So there is a thermodynamic imbalance in whole the planet system. So there all the circulations, it not only over the atmosphere but also within the ocean currents, that is there always. And that is differently is diverting for its equilibrium conditions, or that is one of the reason is some kind of paleogeological cycles. But also nowadays what we have found from the IPCC reports, that it is also diverting or deviating from the paleogeological conditions. So there is a change, and that change because of these emissions issues, more the emissions, more is global warming, so that is capturing the heat. So definitely that absorbed within the atmosphere, and that is getting back. So this circulation patterns also changing. So we need to know that what is happening. If you see a flood in a city, then how we can explain in terms of the fluids. Or if you look some kind of drought conditions, some kind of extreme hydrological conditions, so can we explain in terms of the fluids? Can we understand that what the mechanism or the natural process that is actually happening behind? And definitely we have come a long way from understanding just the flow of fluid. And you know that fluid word was not there, that was fluere in Latin, and that means to flow. So people start looking at the flowing things, the flow in a river or in the wind pattern, wind conditions. So they start to understand that there is something there that is flowing, that is not being static, so it is start to move. So in start to move, they in Latin they start put this word the fluere, and that become fluid in present era of English. So that is definitely the basic definition of the fluid. And what we are looking into this, so we know fluid that is definitely moves, that is not as static as the solids. And if you put a very little force, that actually change its shape. So that is very important for the fluids. And if you look into the micro molecular structure of the fluid particles, they are much far apart than the solids. So there are a lot of gas, and whatever the bonding, there could be some bonding in between, some molecular bonding are there, but these bondings are so weak that they can deform. So dilatations, deformations, so all those are possible when you are talking about the material as fluid. So that definitely we can give examples as a water, we can give oil, we can take even the jelly is not solid. And we are going to talk about the things that we can call the gel as a fluid, although it looks like very much solid. And we will talk about the viscosity, so that you will understand that why these things happen. So density, if we enclose this in a chamber, definitely if you can take a glass and put the water there, and you know the measure the volume of the glass, and then you take the weight, take out the self weight of the glass, and the what is the mass divided by that volume, you can get the density. So even for the gas, if you have the enclosure and put some gas inside, maybe using the vacuum or maybe the blower, so these container, whatever the self weight you take out, that becomes the mass, and the total volume you put in the denominator, and mass by volume, that gives you the density. So density is as simple as that. And we also take a parameter that is called the specific density. Specific. So specific density is nothing but basically the reciprocal of the density. Density we denote as rho. So 1 by rho is our specific density. So that specific density sometimes is very important, because we look not only in terms of the volume but also mass, and sometimes vice versa. So when we need some amount, some quantity that is very similar to the density, but we cannot take in terms of the volume, in terms of the mass, then the reverse can be possible, and that sometimes helps in further analysis like dimension analysis and all. Today in the class of fluid properties, I don't want to put the units. That we may surprise that everyone, every time if you go to the class, talk about the fluid properties, maybe the first or second class, but always there is some units, and we have to remember the units, this parameter and that unit. We don't know what is the story behind and how to remember those units more lucidly, more kind of story like things. that we generally don't cover. Okay, so let us not use the unit today. So I'll take another class about the units, and that will give you some kind of very funny things about the units and how you can remember the units without remembering the exact thing. If you know the formula, if you know a little bit of dimensions, you can pick up your units. So that we will take up in the some other classes. Today we will talk about only the properties. So density, specific density, and then we'll talk about the viscosity. So any real fluid that has viscosity, Newtonian fluids, you may have in your class that what are the real fluids, what are the ideal fluids, and what is Newtonian and non-Newtonian fluids. So if I take a graph by stress and strain, so and if I put down the data that you have a volume of fluid and you are just putting some more stress, so how much the change in that volume because of that. So for real fluids, definitely be a linear graph, and for ideal fluids that has to be a 45-degree line. This is for ideal, and this is real, what you can see anything around. So there is a relationships, and definitely if it is a plastic, there will be some point it will not affect the strain even with the for the stresses. So they are plastic. So there are different types of fluids in terms of their behavior and their kind of representation with the stress, the external work force. Now, how or why this is important? This is important because always we try to control the fluids. When you know that there is a LPG in your house, so we have a very small cylinder, and that maybe weigh just 14.2 kgs. But do you know what is the density of that? And if you check, that is become a liquid, that even not a petroleum gas, and that's why we call it LPG, the liquid petroleum gas. So we have to put the whole volume of gas in a particular cylinder that may be very much utility, that gives you very much usable things, because we cannot keep a very large container in your kitchen and taking the supply for the gas. Definitely there are systems in US, there are like city-wide gas connection systems, so that is different. But when we talk about the LPG connections, so we have to pressurize the gas into the liquid form, and that can be delivered to your home or to your kitchen, so that you can use it for your cooking purposes. So that is there. So we need to know how it behaves. We cannot pressurize, we cannot go on reducing the volume and how much the work we have to do. So there is always an economic point of this. So what are the energy you are using just to change its phase of that particular fluid, maybe for your usability purpose. So these has to be linked, the basic things has to be linked with the utility. So that is very important. So with this we can take an idea of different type of fluids and how it behaves with the external force. So if it is like that, so we can start thinking about some movement within the molecular structure, and that's how not just the density, the viscosity is also important because it is flowing. By definition, it is has to flow. So it has to flow. So definitely when it flows, like if you remember, there is a picture there drawn by Leonardo da Vinci, and he drawn a kind of outlet from a tap into a chamber, and the water is coming out. So definitely there will be a lot of turbulence, lot of mixing and movements, circular, mostly the circular patterns, depending on the what are the opening of the jet or the faucet or the tap, and also the container height, volume, etc. So depending on that, there will different types of the flow formations. So when you look at the flow formations, and you can see that not every point is moving similar to the other. So that is more kind of natural flow, I can say. But when you start understanding the flow from the basics, let us take it is a kind of channel, long channel, long enough that it does not have initial turbulence. So maybe you are putting the water here, and that after having initial turbulences, maybe we can use some walls with the holes, and that become quite parallel to each other. So we'll talk about the flow properties, that we'll understand that what is a laminar and what is a turbulent. So this side definitely more turbulent, and this side is more laminar. So if you see that flow is going through this channel, and it is having that kind of very much parallel pattern, and what we can do, we can just inject some kind of dye here. Maybe you can use different dyes, different colors, and put in different sections. So then you can see that if it is very purely laminar, so the color will be distinct for that part of the channel where we are injecting it. So it will continue to some extent, but definitely there are wall effects, there are some internal turbulence still there. So some point of time they will mix up. So you can see that if this is become very much kind of pleasant conditions, or not much external forces are there, they try to slip, they try to move one layer above another. And that's how I just put the example of that faucet from Leonardo da Vinci. He imagined it as bunches of hair. Definitely hair, if you talk about the three-dimensional flow, imagining as a hair for every line, every streamline of liquid is very important. But if you talk about two-dimensional flow, you can think of it is a kind of tape, very much thin in its thickness, and also had some width, and it is flowing one another parallelly. So when it moves or try to move over one layer above another, there always some kind of resistance. And you can just imagine that you are just pushing one block over a rough surface. You have to push very hard, very definitely you have to overcome something. So that is a resistance. So that resistance also there in the liquid. You may think of this is just kind of deformative element, so it does not have anything. But no, intermolecular resistance is always there. But definitely for gases is very less, for liquid it is still there to some extent, and that's how we have to look into the property of the viscosity. So what does viscosity mean? It's not density, but it's the property of a fluid that will help us, that will tell us that how the fluid will flow, because always there is a internal frictions, internal resistance is acting within the liquid, and also definitely with the surface. So if we have a channel and we just flow water, pure water, so the velocity it takes, or the time it takes from one point to another point in the channel, that is much less when you put very thick oil, maybe lubricant oil, or even you can try the grease. Grease doesn't move at all, right? So that oil, you compare with the water, a very thick oil or dense oil, so it will take much longer time to move from one point to another point. So that means maybe you can think of a similar liquid that is very similar density, some kind of oil are there, and you can just compare the, even there are liquids, they have the same density or very close density, but still they move, one is faster and is slower. So why? And that is the viscosity. So viscosity we generally define by the stress and strain. So it is because for Newtonian fluid we understand as that is du by dy, and that is dilatation du dy. So this is basically the dilatation. So if you think of any small cube here, or maybe a plate, so due to different movements at the different layers within this, it will move differently, so it will little bit of deform. So this is generally what we take the longitudinal velocity, the u, and y is the depth, so depth of the channel. So within that, this shear stress that is being created or that is being acting for this particular flow, that will be kind of proportional to du dy, and this proportionality constant, that is basically the viscosity. This is and viscosity is affecting or relating the stress, what are the external forces that is happening, and how much is the dilatation within this liquid. So that is the viscosity, and this viscosity is being used everywhere. Viscous, how viscous is the atmosphere? Do you know? Because when you ask some rocket launcher, the NASA or the ISRO engineer, and you can ask this question, that how important the viscosity for the rocket launch. I visited that Kennedy Space Center in Orlando. From Orlando to this KC, you have to go to the island. I went there by driving, and I saw there's elaborate facilities from testing to launching. But whenever you talk about the launching conditions, what are the suitable conditions, the atmospheric conditions, what are the is there any storm, is the this kind of the fuel that is ready for to be injected, to be burned. So all the way, all the points, this viscosity or the fluid properties become very important, and that's how we should know these things from the basics. Maybe if you don't remember, just remember the story, and that definitely help you to keep it in the mind just beyond that, those formulas or the units that definitely you didn't forget every time. So let's see, and what this next story we have. Okay, so viscosity, density, these are mostly the physical properties, and I'm not covering more on that. And definitely, when you go the proper green engineering program, will go much more elaborately with this properties, the physical properties. And let us talk a little bit about the chemical properties, because chemistry is also important. It's not always for the civil engineers, but for the chemical engineers. And when you talk about even for the environmental engineering, you talk about the atmospheric reactions, and we are talking about the whatever the clarifoculations, or maybe we are talking about the filtration, and when we are injecting some kind of enhance some kind of extra chemical or quantity for do that process, you definitely should know the chemical properties, not only for the water, the what is the incoming water. And if you're talking about the water or wastewater engineering, so there are a lot of things getting mixed with the water when it comes to the treatment plant. So I have visited a lot of treatment plants right from my bachelor days, and there we saw even very greasy water that can come, and you don't even imagine this is a mix with water. And I went there, that was a industrial effluent treatment plant, and it's a lot of oil. And definitely, if you don't know the chemical properties, it's very difficult to have the proper treatment of it. So you have to remove the scum, you have to remove the oil. How to remove that? What the density of that particular oil? That may not be a single oil, there could be a mix of different oils. So if you don't know, even some of the oils also have other chemicals, and that either getting dissolved, or maybe suspended, or maybe started reacting with the other properties. So how much dose you want to put when you talk about the treatment? So we should know the what is the pH of water. What is P? This H. H is for hydrogen ion, or H plus. So this pH means the density or the presence of H plus ion, and this is a negative in the sign. So more the H plus ion is present, the pH value should be less. So that's how acidic range is less than 7.4. 7.4 or 7 is basically neutral, and more the acidic, that means more the H plus ions present, pH reduces, the pH value reduces. And when basically having less H plus ion, rather more OH minus ion, then the pH value should increase. So that is basically the representation of pH. And why this pH is important? Because when you talk about the reactive powers of the liquid, you always have to count that how much the H plus or OH minus ions are already present. It is not only for the chemical reactions, but also for the biological reactions. So there are different microorganisms. They work mostly in the acidic range, and some definitely work in the alkali range. So what is the actual pH that we have in our fluid? That is very important to know. And that's how if you have done 11 and 12 standard classes, so that is we use a litmus paper, the color, the pink color, small paper, definitely you remember. Okay, so that paper, if you just put in, that will become more reddish, so if it is acidic, but more bluish if it is alkaline. So that's how we just determine the range. But definitely when you talk about the very specific values of pH, you have to use some kind of sensor, some kind of instrument that is very much useful to identify the pH. We sometimes use a pH meter, and definitely we use some kind of electromagnetic circuit, and that tells that what are the conductivity within this. So more the ions, definitely more the conductivity, and it is positive or negative. So depending on that, we can find out that what is the exact value of pH that we should have. We also have to know that what are the other presence of other minerals, maybe calcium or magnesium or sodium. And sodium ion presence is very important because the salinity in water is depends on that. So if you are talking about the salinity in the field, in the agriculture field, so more this ions present there, so that is create more salinity, and saline water is definitely not good for the plants because they penetrates through the soil, through the stem or the stem cells, the cell walls, and they deposit there. So that inhibits the normal processing of the plants or the plant cells. So salinity is very big issue in agriculture, and definitely if you don't know these properties of the fluid that you have, that may not be pure water, that would be maybe saline water or something like that, so you'll be in the trouble. So you should know that what the properties we can have. So these are the few chemical properties that we can determine for the fluids, and also there are other properties that is important for the chemical reactions. Presence of gases also important. So if you talk about the atmospheric conditions and atmospheric reactions, that what are the particles of acids or the particles of some other gases that is present there, that actually controls the reactions, the natural reaction that happens within the atmosphere. So that definitely having some kind of acids, H2S, H2SO4, or maybe hydrochloric acids, but definitely they are in the form of gases, and mostly in the atmosphere the sulfur and the chlorine they be separated, because if you go above more the lighter atmosphere is there, so they are separate. But whenever they comes in contact with the water vapors, and they create a lot of these acidic conditions. And acidic condition, you heard about the acid rain. Sometimes rain is some kind of yellowish color. Okay, so yellowish color rain or some kind of brown rain, and these kind of happens depending on the how much the other gases or the minerals present in the atmosphere. So that is very important for atmospheric science. Also the air pollution people that who controls the conditions, because more the acidic conditions, more will be the chances of reactions that may be creating towards rain, or if there is a lot of particles around, or the density of the water vapor that is very high, so they'll be causing of rain. and that rain maybe flush out the other kind of toxic gases like NO2 and NO3 or sulfur. So if that are flushed out, then your atmosphere is clean. Also that flush out the particulate matters. So if you can flush out, or if the naturally it can flush out through the raining, definitely that is beneficial. That makes the air quality better. Nowadays you may heard of this artificial rain and cloud seeding. There are a lot of activities, there are a lot of geoengineering, sometimes we call large scale engineering, that is going on. But when you talk about the decision making, that what the particular properties of those activities or those elements that we are going to use that for that particular process or that particular activity, that is coming into the basics again. So you should know what are the chemical or reactive conditions present there, so that what you put in, what you are maybe explaining, or maybe you are buying a lot of chemicals, that what type of chemical you should buy and what quantity, how you spread it, and when you spread it, what are the temperature conditions, what are the moisture conditions. So in those whole process, if you don't know the atmospheric conditions or the fluid properties, that will put in more problem. So chemical reactions or chemical properties, that is very important for the fluids. And then we talk about the thermodynamic. So physical properties we started with, and physical properties, as I told, that is basically how you feel, how you see, and what you get visually. So density, color, also the temperature that you can feel. You can just dip your finger in a jar of any other liquid, so you can feel that how cold it is or how hot it is. So this also become a thermodynamic properties. So temperature is also important property of a fluid. So definitely you know the universal gas equation, that is PV equal to nRT. So if you have not studied yet, it will be definitely in your some other classes. And when you take this green engineering program courses, will go from very basic to this formation of this kind of equations. So if you see that this is pressure, that is also an important property of fluid, because the fluid, mostly the gases, is very expanding in nature. So they try to cover as much as volume they can, because that's basically because of their low intermolecular attractive forces. So if you try to contain them, definitely you have to put the pressure on it. So just put into a cylinder or maybe a closed container. So how much they react, what the stress they can create over the walls. So that is basically the pressure. Yeah. So pressure, volume, we already talked about the volume, how much volume it can cover, and molecular numbers, molecular density. So more number of molecules, definitely it should take more space. Not always, because it depends on other properties. We have the universal gas constant, and we'll talk about that in some other classes later. Last one is not the least, and that's we are talking about. So this is temperature T. We measure it with different units Remember, I have said that we are not going to talk about the units today. Let's wait. So T, temperature. Temperature, how we can feel. That is basically a thermodynamic properties. The more energy it has, it may be any element, and it depends on that how much thermal energy you have in what you try to feel your finger. So if you put your finger in a ice and immediately put in a boiling water, you don't feel the things that's boiling. Why? Because that temperature difference. Before you basically take out your finger, nothing definitely happens because your finger is already sense the low temperature. So definitely you have to take out your finger quickly, otherwise it will burn. And that changes is important to understand the temperature. So how we measure the temperature is about difference in the thermal energy. So more the thermal energy, it has to have a more higher temperature, and that's why we use a thermometer. Definitely you have seen the thermometer because sometimes of your life you have the fever, and fever your mother has to put the thermometer and see how cold or how the body temperature it's there, and if it is more than what is that, do you remember what is the ideal temperature for your body? So 80 something, 80 plus, some 88.4. So if it is more than that, even definitely if it is crossing 100 Fahrenheit, oh sorry, I'll not talk about the unit. So that is basically the very old dizzy conditions. You have to stay at home, and nowadays you know the COVID situation. So if you have fever, so sometimes you have to check for the COVID, right? You should. Anyway, so temperature is a very important property of a fluid, and nowadays when we are dealing with the climate change, we have to see the temperature in detail and the variations. You always know that if we go from the surface where you have the maximum heat. So if you imagine you are just starting from the kind of plateau region, very much flat region, and go up trailing over the mountains. So more you go up, temperature will reduce. So temperature reduces with the altitude. Temperature also reduces if you go from equator to the pole, and also reduces over the daytime. And all of this because of the difference in the thermal energy. So thermal energy, thermal equations, thermal properties of the fluid becoming more and more important nowadays, because what we used to have the surface temperature that was quite normal, and nowadays as the temperature is rising, maybe you heard of this 3.5 4 degrees centigrade is increasing, 4.5 degrees centigrade may increase in the next few decades. So there is something is changing what the equilibrium temperature was there, and that maybe 1.5 degrees, 1.5 degree, right? Okay, fine. So there was some equilibrium temperature, and it is increasing, and that is because of the global warming. So if you look at the surface is heating, and that heat also definitely penetrates through the soil as well as through the atmosphere. But has to be something, some element, that is some solids are there, and but for the transport thing, you know, the different transport mechanism, we will definitely come with the fluid flows of fluid dynamics later on, that what are the different fluid flow patterns or thermodynamic processes that basically helps the fluid to move or the heat energy to transfer. So that will be there. So that is basically causing the heat energy to transfer from one point to another point. So there are different processes, radiation induction convections. So due to those, the temperature or the thermal energy basically getting transported. So more the layer or more the conditions, even you do a experiment in a lab, you just take a bucket of liquid and you put a heater at one kind of point or one corner within the bucket. You should not take definitely the plastic bucket, we should take some metal bucket, and be careful of the electricity. So when you put that immersion heater and you just start kind of heating up the water from one point, then slowly some larger area, some larger volume, that will getting the rise in temperature, and that is because it absorbs more thermal energy that is being emitted by that induction or immersion heater. So that is basically causing the temperature to rise, and because the low intermolecular attractive forces for the fluids, that thermal force is causing the fluids to expand much more faster or deform much more faster than the solids. So that's why you can see that there are a lot of storms nowadays, and the speed of those hurricanes, cyclones, and maybe some other big storms, they are moving much more fast towards the land, and that is causing more havoc. So why this happening? And that is because mostly of the absorption of the thermal energy, and that we can identify using temperature. That is definitely one of the fluid properties. And know, you know, maybe some kind of reconnaissance this planes are there, storm catcher, these are the words. If you search in the internet, you will find this. And this is basically go to the storm area, go to the center of the storm, we call it I, and try to measure the temperature variation. Why? So that actually help us to identify the how much energy, thermal energy it retains. More the energy it retains, more it can cause a devastation. So that's why it is very important to understand the thermal properties of fluids. Also, as we are talking about this equilibrium, the PV equal to nRT. So what are the pressure and volume, the work done, that will be creating some kind of energy transfer to the liquid through the molecular numbers and the this universal gas constant. So if it is an enclosed chamber, you are putting more pressure, volume is reducing, and that is basically containing more heat, so the temperature may rise, right? Okay, so let us move on to the other properties like entropy and enthalpy. And those two we are trying to cover today, and later on maybe we can cover in detail. So entropy is a very common word in research. So if you look in any kind of mathematical, statistical, or thermal engineering, or even the climate science papers, so entropy is everywhere, because it gives the measurement of the internal energy that does not transform into the work. So it is inside, it is always inside in those chemical bonding, in those particular molecules, molecular structure, they keep this inside, so that is not available for the outside work. So amount of thermal energy is not available, and sometimes we use the eta for this, and we'll come to the notation later on. So that is entropy. But when you talk about the total energy that it can have, so that definitely includes the amount of energy it can be used for work done or the external work done. So then we use this term in help. So these are the thermodynamic properties. So we'll definitely come into the more details on these properties and how these are exactly important to some practical problems. So we'll give you more details and more insight, as well as we can do some numerical problem solving in the formal classes of green engineering program. So that is basically the story I want to tell about the fluids. We were talking about the properties. So as you know that without knowing the properties, handling anything is very dangerous, right? So you should know the properties, because you are engineer or maybe scientist or maybe industrialist. So wherever you have to take decision about materials, you are taking decisions about your research work, some point this basic properties have a role in your decision making. So that's why this story, the part of this story about the fluid properties is very important, and I'm just trying to tell as much as lucidly I can. Not always. I have to use some formula. We definitely have to use the derivations, but that's not all. So we have to see some kind of funny sides of those equations, some kind of funny side of the formula, and also the units that I definitely catch up in the next class. So this is kind of inaugural sessions of these subjects, and since we are looking into the whole problem that I just mentioned, from the formation of the earth, that may be the plasma condition, then it become the liquid, and then it's solids, and as we are proceeding towards the space age, we have to think about more specifically in the properties of the fluid, and sometimes we are challenging. If you see some kind of physics experiment, we are trying to challenge the fluid properties, the superconductivity, the fluidicity. Even we trying to break down the viscous conditions in some kind of fusion things. So when you talk about the nuclear reactors, so those are things are there that may be the scientific way forward, but not only for the very critical scientific experiment, but even for the industries, even for the practitioners. These fluid properties give you much more control in your decisions, in your calculations, or maybe in your reports that you prepare. So we need to know this. We need to know this, and we need to remember all of this very clearly. Sometimes we are using very sophisticated equations, maybe RANs, or maybe kind of derivations, very big definite derivations. But if you just miss one or two things in the different steps that you use for the derivations, without knowing the proper properties of that particular fluid you are talking about, then you are in trouble. I'm there to tell or take you out of this trouble and try to help you as much as I can. So stay tuned in my channel. I'll tell you more about the fluids, and there'll be kind of information will be available on my LinkedIn profile. So just check that before you're coming in. And sorry for live streaming was not possible today, and definitely as time to come, I'll try to bring that live streaming. Otherwise the comments will be open there, and you can just put your queries there, and I'll try to take it up. Okay, thank you. Bye bye.